Hello everyone! In the last tutorial we started looking at the control board. We talked about how the force field is derived from the combination of two simulations, which we can call the reactive simulation and the passive simulation. The reactive simulation is a linear simulation that uses the music spectrum to build its growth function. The passive simulation can be a linear simulation with a non-reactive growth function, a Perlin noise distribution, or a custom image. We'll look at this in detail later. The influence of these two simulations is regulated by these two power sliders here. Power is the contribution multiplier for the reactive simulation, M power is the multiplier for the passive one. Today we are going to look at how the reactive simulation uses music to build its growth function. The panel dedicated to creating the reactive simulation growth function is this one on the top left corner. At the top we find the input drop-down, where you can choose from all the Windows input devices. If you want to use the audio coming from your PC, you can use a sound card that features audio loopback, or a free software like VB Cable. After choosing the input device, we can see the spectrum populating this section. You can apply a global gain using the slider above it. Lenia Mixer uses the frequencies to create the growth curve, but not directly. It offers a collage-like editor to customize the spectrum. Below the spectrum visualization, there is the collage editor. It's composed of 4 bars, 2 input bars and 2 output bars. Let's look at the 2 thick bars in the middle. Right now, there is a default segment that covers all the frequencies, both in input and output. We can scale and move the top segment to capture different frequencies, and the bottom segment to paste them into a different portion of the growth function. You can delete a segment by holding Ctrl and right-clicking, and create a new one by holding Ctrl and dragging with the left mouse button on the top bar. By selecting a segment, you can customize it using the parameters on the right. You can smooth the edges, apply a global smooth, introduce a threshold, add a temporal smooth, and you can also add a Gaussian bell to the output value by choosing its height and width. On the right, there is a vertical slider to amplify the signal of the selected segment. Besides segments, another element you can use to customize the growth curve is the node. By holding Ctrl and left-clicking on the very top bar, you create a node. A node reads only one frequency, and uses it to modulate the height of a Gaussian centered at the position of the output node, which appears with the same color on the very bottom bar. For the node, we can customize the bell gain parameter, which increases the starting height of the Gaussian and the width of the Gaussian. There are also 2 toggles. The additive toggle adds the Gaussian's contribution to everything else it overlaps, while the auto toggle enabled node's auto mode. Instead of picking the exact frequency of the input node, it takes the intensity of the nearest peak in the spectrum. The last parameter uses the intensity of the input to shift the output Gaussian by the shift amount. You can modulate the overall intensity of the node using the vertical slider on the right. Below the spectrum editor we just described, we can see its result. On top there is an infinite slider that shifts the whole result left or right. In this visualization, besides the resulting growth curve, we can see the color palette in 2 bars, one on the top and one on the bottom. In the middle there is a histogram showing how many pixels fall into each portion of the growth function. By moving the bottom slider, you can artificially alter the neighborhood analysis by spreading the results. This visualization is very useful to understand how many pixels are reacting. In the next tutorial, we'll take a look at the neighborhood mask editor. See you!